Dr. Nick Aumen serves as the Regional Science Advisor for USGS activities in the Southeast region and coordinator of the USGS Priority Ecosystem Science Program for South Florida. His research is focused on the ecology and restoration of the greater Everglades ecosystem. Prior to his current position with USGS, he was an associate professor at the University of Mississippi, research program director of the South Florida Water Management District, and was also an aquatic ecologist and water quality branch chief at Everglades National Park. Nick is well known to many in the San Francisco Bay Delta community and for his extensive experience in multi-party adaptive management efforts and in collaborative science, and we welcome him.
Thank you. Very happy to be here. And I recognize that maybe the only thing worse than being the last speaker before lunch would be the last speaker before happy hour. So being number 2 on that list, I'll try to keep moving. I do want to recognize my co-author on this, Jay Antho Bisacaro, is here, and many of you know Obey. And he helped me with a lot of these presentations and also has been a long-time resident and practitioner in the Everglades world. So he's also a font of information and wisdom for you during this two days that we're together. I want to emphasize that although I run this Everglades Priority Ecosystem Sciences program, I'm up here as sort of representing our broad Everglades ecosystem effort across the spectrum from sort of our perspective of our Everglades Restoration Task Force and Working Group. And I also recognize that the value that you get out of our presentations aren't necessarily from our presentations per se, but in interactions that come afterwards, because it's hard for us to tell which of our experiences and mistakes and successes would be most applicable here. It's going to be more up to you to see things that we mention and say, hey, we want to get more information on that. So I welcome that continued interchange and interplay between these big efforts. I also want to apologize ahead of time for all the acronyms on my slides. That's just, I guess, one of the things we have to bear with these big efforts. But if I had spelled everything out, the slides would have been very small font. All of the things that I put up here you can find on Google, and also I will try to explain them as I go along. So sorry about that. Oops, a little too fast. So as you've seen on the maps, the Florida Everglades, we call it the Greater Everglades ecosystem, spanning all the way up from the north, which is the headwaters of the Everglades near Orlando, and then through the upper chain of lakes, down through the Kissimmee River watershed, Lake Okeechobee, all the way down through the agricultural areas into Everglades National Park, the water conservation areas, and out into the east and west coast estuaries and Florida Bay, all the way out to the reef track. So we have a very expansive definition of what we call the Everglades. But I think that's important because everything we work on is linked, as we know, as ecosystems function. So having that linkage and that broad definition of the Everglades, I think, is very important. That area that's shaded represents about 18,000 square miles, just to put it in perspective. And I really liked Mike's map that he had up first that shows the relative locations of all these places and the sizes. It gives you an idea of the challenges we face. I put this slide up for a picture from the space shuttle to show you some of the special features of South Florida that give us headaches sometime. First of all, I'll just point out that it's a very, very flat landscape. When you go from Lake Okeechobee, which is right there, down to Florida Bay with a span of 100 plus miles, you lose elevation of about 20 feet. And so our ridges you have to take them with a grain of salt. When we say it's a hydrologic divide, you're okay if you smirk at that. There's a sign in Everglades National Park when you're driving the main park road that there's a sign where the two main watersheds divide, the Taylor River watershed and the Shark River watershed, and it's called Rock Reef Pass, and the sign says, you're now crossing Rock Reef Pass, elevation 1 meter. And so that's kind of the way we work, and that certainly gives us a lot of problems in terms of managing water. I mean, when it rains a lot, it stays in one place. It's like pouring water on this tabletop. And that's always given water control people and flood control people big headaches on how to manage the system. But it's still something we have to deal with. Also, I point out, it's a little hard to see in this slide, but I call this the Sea of Humanity. On the very southeast coast of Florida, the first developments were on the southeast coastal ridge. Again, 20 feet is our southeast coastal ridge, but that was the area that was first developed. And of course, it's expanded rapidly since then, also over on the southwest area of Florida and South Florida. And the big future development area is going to be in this area, south and around Orlando. It's projected to just be huge population increases in the future. But again, South Florida also suffers from I guess, the history of having some very sensitive natural areas jammed right up against urban and agricultural ecosystems. We have some very sensitive ecosystems. The Everglades, you may or may not know, in terms of nutrients, Mike mentioned that, or somebody mentioned, very small increases in nutrient content can have big implications on Everglades ecology. And unfortunately, most of our natural areas are downstream of the ag areas and urban areas. So that also gives us a little bit of a challenge to deal with. I think that's all I wanted to show from that slide. As far as history of water management, Florida is a fairly young state in terms of its human development and change. First of all, most of those changes began in the late 1800s, about 1890, when Hamilton Diston began to modify the watershed somewhat. But people recognized the potential for Florida, particularly for agriculture. Subtropical climate, we don't have really cold times. Our 2 seasons are wet and dry. And a vast extent of flooded lands during the wet season kind of precluded development. It made it difficult to put in ag development in urban places. And as development progressed, there was an increasing pressure to drain this worthless swamp, is what it was called, for many years, and an effort to reclaim these areas and make them useful for agriculture. And just to give sort of an example of a big event that changed the way of thinking of what we needed to do was in 1928. There were already quite a bit of agricultural development south of Lake Okeechobee. There were some small levees around the edge of the lake to try to create this farmland. And a hurricane came across Florida. And because of the large seiche that it produced on Lake Okeechobee, it created a big storm surge that overtopped those very small levees, and about 3,000 people drowned in 1928. We'll never know the exact number because most were, unrecorded or undocumented migrant workers in farm fields. There were mass graves in West Palm Beach. It was a huge event in terms of a natural disaster, and it still counts as the third costliest U.S. natural disaster in terms of loss of human life. And so that got everybody's attention. And then in 1947, there were back-to-back hurricanes about 3 weeks apart. And those came across Florida. They didn't cause the loss of human life, but they did result in most of South Florida being flooded for about 3 months. It was really quite a situation. And finally, in 1948, the people of Florida said, we've had enough. We've got to do something. So Congress authorized what is called the Central and Southern Florida Flood Control Project. And this was this massive civil works project intended to both provide flood control and water supply. So it was authorized in 1948, and then it took a few years for design, and then over the next 3 decades, this large system was put into place that really changed the face of South Florida. And just a couple things I'll mention about it. It was designed primarily for flood control and water supply, and the story I tell is the engineers, when in the late 40s and the early 50s, when they were developing this, they had to look ahead, as engineers do, quite a way into the future and say how many people are going to live in South Florida in the year 2000. We need to over-design the system and make sure it's going to handle this big population that's undoubtedly coming. So they went through all their estimates and everything, and then they multiplied that estimate, put in a safety factor. Their final number they came up with for the year 2000 was 2 million people. They were off by a factor of 3, but the system still works remarkably well. But unfortunately, at the same time, it's created some environmental problems that began to be recognized just as some of the components were being constructed and put into place. When it was authorized in 1948, most of our field of ecology was in its infancy. What we know now is vastly different from what we knew then. And also, I always say, put yourself in the perspective of a resident during that time who just, either there would be half of the year they couldn't get enough water, or the other half of the year there was too much. So here's just sort of the development of that system that was put into place. As I said, it was 18,000 square miles, 16 counties from Orlando to the Florida Keys. And we have to, I don't know if we have a contest about the number of miles of levees and canals. I don't know what it is here. We claim 2,100 miles of canals, 2,000 miles of levees and berms, more than 600 water control structures, and 70-plus pump stations. And these pump stations are quite massive and expensive. The difference, again, when I think of the Central Water Project and examples in California, we do a lot of pumping massive quantities of water up short heads, relatively small elevational differences. So we have these big pumps that move a lot of water. Here you have a lot more topographic relief to deal with, but it still ends up being a lot of expense. One of the other peculiarities we have is our pumping stations are all diesel powered because they have to be operational during hurricanes. And so all of our pumping stations can't be on the electric grid. They have these massive diesel pumps and huge tanks outside of diesel fuel, so that's another little bit of a difference. And now about 8.1 million residents. That number is projected to double in 30 years, which boggles my mind when I'm sitting in 10 lanes of traffic in South Florida. But I guess that's what is here to come. And as I mentioned, most of it on the southeast coast, southwest coast. You see the development up around Orlando, and that area between Orlando and Lake Okeechobee is where we think the next, pretty much everyone projects the next flood of development to occur. And a lot of agriculture, as I mentioned, interspersed here. Part of the reason of putting in this flood management system was to create land that's good for agriculture. We're a very large beef cattle state, actually one of the top states in the country. A lot of course, sugarcane, winter vegetables, tropical fruits, you name it. We grow it. Probably California and Florida are the two examples always of those kind of winter production crops that you don't find anywhere else. And finally, in the midst of all that, I mentioned earlier these vast protected areas interspersed and downstream in a lot of cases from these vast sort of agricultural enterprises and urban development. And for example, the Everglades agricultural area is this area just south of Lake Okeechobee is about 700,000 acres of agricultural development. Most of that is sugarcane, but there's a lot of vegetables and other rice production, et cetera. So a lot of that land is in, very active agricultural production. If you're in a small plain at 2,000 feet in the middle of that, you can see sugarcane for as far as you can see in all directions. Some of you may have been to South Florida and see some of this. So a lot of components that came in as part of this modification. We'll start with river channelization, really well known as the Kissimmee River, which was this meandering floodplain river that went from the upper chain of lakes, the headwaters down into Lake Okeechobee. And then as part of this Central and Florida Flood Control Project, that most of that river was channelized. That project was completed in the early 1970s. Took about 15 years to channelize it, at a cost of probably in those dollars $10 or $11 million over that course of time. And now we're undergoing a massive project to undo a third of that and fill in that channelization and reflood the river floodplains. That's just about to be completed after about 20 years, and expenditures probably pushing to $800 million to undo a third of what we did. So that's just sort of something to think about as we move forward. The levee around Lake Okeechobee, certainly, and as we progress, the compartmentalization of what are called the water conservation areas. These are large swaths of former Everglades that we use as sort of storage areas. Florida gets most of its drinking water from subsurface aquifers, and so these water conservation areas are designed to store water when it's wet, keep it so that we have a way to recharge the aquifer, the shallow aquifer, during the dry season. And they're still Everglades, but they've been impounded. So just the impoundment of once was this sort of river of grass, this free-flowing system, also has had its ecosystem impacts. And the northernmost one, Water Conservation Area 1, is the Loxahatchee National Wildlife Refuge, about 140,000 acres of what's left of the northern Everglades. Protective levees all the way down surrounding the agricultural area, dividing the urban area from the ag area, and then a vast network of drainage structures to provide that flood control and water supply feature that the project was designed to do, including salinity structures on the coast in order to keep out and help keep seawater at bay, which now, of course, is becoming a major problem with climate change. I throw in this map, which is a facility map from the South Florida Water Management District, and I just put it in here to show you the complexity of the managed system. And you can just get an idea from looking at that, the number of canals and levees and pump stations. And I'm going to zoom in just on one area. This, again, is the Loxahatchee National Wildlife Refuge, or Water Conservation Area 1. These are constructed wetlands that have been put in place to reduce the nutrients coming into the Everglades. And every one of those symbols that are all jammed together are either water control structures or sampling stations. It's just a vastly complex network. Down further, you can see a list of all the structures and pump stations that are moving water around. And to make it even more complex, just in the water management scheme itself, using this area as an example, the Water Management District controls the inflows, the gates and the pumps that feed water in, but the Corps of Engineers controls the outflow. So right away, there's got to be a lot of good communication and coordination between those entities to manage this area. Even though it's now an impoundment, it's still, part of the remaining Everglades. And we've lost about half of the spatial extent of the Everglades with agricultural and urban development. And so a lot of the work that I'm talking about here is designed to protect that remaining one half. And one other thing I just want to mention, just as a side note, and maybe Obi can talk about this more, after the flood control district was created in the late 40s, in the early 70s they created the Water Management District Network in Florida. And I think there's some similarities with California, but one of the advantages was it divided Florida into 5 water management districts. And the cool thing was each of those are roughly delineated by natural drainage boundaries. So you have one entity that can control a lot of things in a natural watershed. That's really important, rather than having multiple entities having to make all those decisions across agency boundaries and stakeholder boundaries, et cetera. So it is a good system. It has a governing board that we'll talk a little bit about in the coordination and communication part later on. And it's also a very large entity at its peak, probably 2,200 employees. And I think its peak budget was in 2007 was about $1.4 billion. For the agency budget, it's down to around 700,000 or 800,000 right now per year. Our major resource management issues, that's your test. If I see you later in the hallway, you're going to have to be able to recite these back to me, but they're very common in most of our large-scale ecosystem areas. First of all, the altered hydro pattern, and that is because we've put in this major sort of water management system that has really cut across and interrupted what was the natural flow of water from Lake Okeechobee and north, from the upper chain of lakes all the way down through the lake. When the lake was much larger than its current boundaries during the wet season, it would overflow the natural sort of boundaries of the lake, flow down through what's now the water conservation areas, through the Everglades, which Marjorie Stoneman Douglas termed the river of grass. So this very broad expanse of sheet flow, relatively shallow, and moving relatively slowly because of our lack of topographic relief. But that was a water-based system. The Everglades is still and always was a water-based system, and we've made some big changes to that with this drainage network. And as I said, it's a very successful drainage network from its flood control and water supply purposes, but it's created a lot of environmental problems, including alteration of the depth, distribution, timing, and flow of water. And so that's one of our major efforts, and when we talk about what are we focused on in terms of restoration, we use the term of just get the water right. If we get the water right, that a lot of other things we hope will follow, and there's a lot of good science behind that to support it. Degraded water quality. As I mentioned, the Everglades very sensitive to small changes in nutrient content, particularly phosphorus. It's a phosphorus-limited ecosystem. And when I mean sensitive, I mean that going from 10 micrograms per liter of total phosphorus, so that's all forms of phosphorus, dissolved, particulate, organic, inorganic. Going from 10 to 15 can cause a change that may take decades to undo. And again, those levels are unheard of mostly in any other natural system. It's just a unique feature of the Everglades, the subtropical setting, the underlying limestone, which absorbs phosphorus. And so we have an additional hurdle of not just dealing with nutrients, but dealing with them at such a level that management opportunities are really limited. I mean, think about it. What can we do to get concentrations down to that level? It's really a big challenge. And in water quality, phosphorus is certainly not the only thing. Nitrogen, all the other nutrients. We have a big mercury problem, which I know is common to some of the other ecosystems, and we've had a major mercury research program going on for decades. And I know some of the results of that have been used in other ecosystems. It still remains a problem, and we know very well that it's tied, the methylation of mercury, turning it into its sort of toxic form, is closely tied to carbon and sulfur cycles, which brings in all kinds of other management implications, particularly with sulfur. Non-native plants and animals were kind of ground zero. If you haven't heard about Burmese pythons and you're living somewhere in an isolated place because it's been big news, but that's just one of just dozens and dozens and dozens of very threatening plants and animals that have really, in many cases, outcompeted
our native species and are causing major problems. We're spending vast amounts of money removing melaleuca, Brazilian pepper, Australian pine, Lygodium, which is a fern, which is very difficult to get rid of. In the animal category, again, you know about the pythons. One thing you may not know is that in Everglades National Park, the pythons have almost completely eliminated the medium and small mammal population in 1.4 million acres. They have completely eliminated. You cannot find in the park, you cannot find marsh rabbits, raccoons, otters, even bobcats. Anything that's in that small to medium mammal category is gone. And we still don't know yet even what implications that has on the ecosystem of the park. The food web has been altered permanently, and there's still a lot of science to be done to show the outcome of that in the long run, but certainly pythons remain a big effort and focus of science, as well as some of our newest invaders like the Nile monitor lizard and Argentine black and white tegu. We have some really cute things that come into South Florida. Development pressure, people still want to be in Florida. Every day, we have about 1,000 new residents, a net increase in population of about 1,000. It slowed down during the economic downturn, but I think it's now back and kicking in good shape. A lot of people want to retire to Florida because of the climate, and we don't have an income tax, a state income tax, so everything is done to encourage that, and well as our tourist industry, which brings in a lot of people every year. So development pressure is a big issue, and finally, climate change. When I was on the boat yesterday looking out across the Delta region and thinking about the similarities with Florida, we have a lot of similarities and challenges. And with climate change, obviously the sea level rise is just a no-brainer of how it's going to affect us. Everglades National Park, 60% of the park is at 3 feet or less above sea level. So even some of the modest ranges of sea level rise are going to have a major impact on this crown jewel of a national park we have in South Florida. Another one that I'm trying to get people to focus a little bit more on is rainfall changes due to climate change. And some of the projections we have are, somewhere in the neighborhood of 10% decrease to a 10% increase. And while for a long time I didn't think that was much of a difference, some modeling that we did with Obi and other folks and did a series of papers out of that exercise, a 10% decrease in long-term rainfall coupled with a 1.5 degrees centigrade increase in temperature would result in some really drastic problems. There would be multiple years when Lake Okeechobee would be below 5 feet, and we have never experienced anything below 10 feet. So it's really important for us to know and increase the certainty with which we can predict future climate scenarios, not just sea level rise, but rainfall patterns and temperature as well. So the big restoration programs we have are really focused around restoring what's shown here, this sort of original flow of water, all beginning up here through the Kissimmee River floodplain, Lake Okeechobee, and down through the Everglades. Because what has happened, as I've mentioned, with this really complicated drainage system we put in place, whenever the lake gets high during our wet season, or we get a tropical storm or two, we're releasing vast amounts of water east and west to the east and west coast estuaries that did not have a natural connection with Lake Okeechobee. And that massive discharges are causing all sorts of problems in those estuaries, wipes out seagrass beds, oyster beds. The nutrients that come in, we had a big incidence of harmful algal blooms occurring on both coasts, but especially on the eastern coast. Lots of problems. So what we're focused on doing is, where we can, restore, decompartmentalize, and restore that natural flow of water in the parts of the Everglades that remain. So that's really the gist of the restoration. And in order to restore that flow, we have to do it with clean water. So that's also been a big effort over many years, is making sure that water that we're putting back into the system is clean enough not to cause changes and damages itself. And with those threats I just mentioned, any of those 5, if we relax our efforts on any of those 5, we're going to have problems. Any one of those 5 things can really be, by itself, a major threat to restoration. So I mentioned some of these already. We're working a lot now on sea level rise. The science is increasing on that in terms of predicting it, looking at impacts on the rainfall precipitation. When we have extreme events, which are predicted to become more frequent, and I was the recipient of one of those in my neighborhood, where in a span of 36 hours we got an estimated 22 inches of rain during one tropical storm. My neighborhood was underwater for 2 weeks. Again, even though our average is about 50 inches a year, we never, there's no such thing as an average year. It's very unusual to have an average year. We're either one end or the other of the extremes. All right, let's talk a little bit about how our science enterprise is structured in order to deal with these complex set of problems. I will start off to say that I think compared to some of the systems, I'll say it's a mature and well-developed effort. Please don't interpret that to mean it's a perfect or well-running effort all the time, but it's mature and well-developed. It's been in place for a long time. We've had a long history of working in a collaborative interagency context. We've made a lot of mistakes and we've learned a lot of things, and I hope to mention a few of those along the way that might be helpful to you. But really, one of our hallmarks is how well we work together. And especially in, I can say from my recent experience in the federal world, in the Department of Interior, we have Fish and Wildlife Service, Department, U.S. Geological Service, and the National Park Service. We really function in a lot of ways like one group down there. We don't see those divisions. I co-fund projects with National Park Service. We have scientists working together on joint projects. So that's really, I think, one of the good things that we've developed, I think just through actual necessity of the need to pool our efforts and work together well. As far as the entities that produce science in South Florida, on the federal side, I've mentioned them, USGS, Park Service, Fish and Wildlife Service, EPA has got a big hand in this as well. On the state, the South Florida Water Management District, the Florida Fish and Wildlife Conservation Commission. I don't know why I didn't list it up here, I left it off, Florida Department of Environmental Protection. And also, we have science being produced by the non-governmental organizations. Some of our larger environmental organizations now actually have science staff, pretty mature science staff. And the tribes, I should mention, also have quite a bit of a science effort. We have, as Mike mentioned during the introduction, the USGS program, which is the Greater Everglades Priority Ecosystem Sciences program. That's about a $6 million a year effort that comes in. And that's on top of other USGS money that comes through science centers and ends up in the Everglades. You have something, I avoided the acronym, it's RECOVER, Restoration, Coordination, and Verification. When our major hydrologic restoration project was authorized by Congress and signed by the President in 2000, there was written into that authorization was a science arm called RECOVER, and that is, the co-leads of that are the Army Corps of Engineers and the South Florida Water Management District. Because as a big federal project, a Corps project, it's a 50-50 cost share. The Corps pays half and the state pays half, and so they're at the lead of that effort. The Water Management District over the years has put a huge amount of resources into nutrient removal, and recently has expanded that effort by about $900 million over the next 10 or 15 years to expand the nutrient removal, constructed wetlands, and some of the other techniques used to reduce nutrient input to the Everglades. And they have a very large science program called Restoration Strategies, centered on making sure there's good science going into that future development of that expansion. There is a lot of monitoring going on. Everybody's involved in that, both with hydrologic and water quality. At the center of it is the Water Management District with a vast monitoring network that spans the entire state. I fund some monitoring, Park has monitoring, everybody has all of that information, and I'll mention a little later on how we try to make that all available in one place. The Park also has something called the Critical Ecosystem Studies Initiative, CESI. It's a congressional authorized project. It started out about $12 million a year at its beginning. It's down to about $4 million a year now, but it's funding critical science work. And EPA occasionally does their big REMAP program, the Restoration Monitoring and Assessment, where they do a synoptic sampling of the whole system. They just completed their most recent one last year, and we hope to see the results of that very soon. A lot of players. So one thing I think we have in common with other major ecosystem programs and enterprises is that there are a lot of moving parts and a lot of agencies and entities involved. Water utilities, agriculture, environment, civic groups, recreational interest, you name it. Some of these will be very familiar to you. I've mentioned most of the agencies already involved, but we also have maybe some more or not so traditional agency involvement. A lot of involvement by USDA and Florida Department of Agriculture and Consumer Services, DOJ, the Department of Justice, Because now we're putting bridges over Tamiami Trail, which has been one of the major barriers to flow into the park. One of our big partners now is Florida Department of Transportation. Homeland Security, Department of Homeland Security, when we're working with invasive species, they're kind of at the front lines of preventing things from coming in at our ports. So we have some fairly new collaborations and partnerships that are going that are really important. Have two major tribes in South Florida, the Seminole Tribe of Florida and the Miccosukee Tribe of Indians of Florida, very active in all aspects of restoration. Local government and state, of course, the academic sector. I want to just mention local government for a minute and talk about climate change, because local governments, in particular the counties, the 4 southern Florida counties, that's starting at the bottom is Monroe County with the Keys, then you have Miami-Dade County, Broward County, the Fort Lauderdale area, and Palm Beach County. They are taking an absolute leadership role in responding to the threat of rising sea level because they're already experiencing it. We had an event downtown Fort Lauderdale during a recent king tide with a local congressman when, this was scheduled to, we timed this, of course, to be there. We were in a real estate office that was the name of the real estate office was Luxury Real Estate Properties. They focused on high-end properties in downtown Fort Lauderdale. We got there at 9 in the morning. The doors were barricaded with sandbags. There were barriers on the street. Everything was completely dry. You're going, what's this all about? By high tide, which occurred at 11:30, that street was under 1.5 feet of water. Seawater was gushing up out of storm drains like little fountains, and that door, the front of the business, would have been, if that's not for the sandbags, there would be water coming in the business. These king tides, these seasonal tides have always happened, but clearly the severity of them are getting worse. They're getting more severe, and the local governments recognize they're going to have to start doing things now, and so there really are investments in planning. Each county has a climate change coordinator in place. A lot of the even the smaller municipalities, some of them have sustainability and climate change people in place. So some of the leadership's really happening first at the grassroots, if you will, from the government standpoint. How are we organized to deal with stakeholder involvement? Well, when the big restoration project was authorized in the year 2000, it created what was called the South Florida Ecosystem Restoration Task Force. And that is a sort of cabinet-level federal entity as it started out, with sort of cabinet-level people at the top. It's chaired by the Department of Interior with the Secretary of Interior at the chair position, which is normally delegated down to an assistant secretary level. And then all the other members, like the Water Management District, would be the executive director or chair of the governing board and so on. And so that body meets about twice a year. But under that is the South Florida, I'm not sure why it's doing that. I'm not pushing anything. About every 3 months, the South Florida Ecosystem Restoration Working Group meets, and that's the working level. It's about 50 members that cross all those boundaries I mentioned before, from federal government, state government, local governments, tribes, academia, NGOs, public, private citizens, you name it. That's where the rubber hits the road. That's where the coordination goes on the overall restoration. And then under that, there's something called a science coordination group, which I currently chair, that's sort of tasked with being the communication and the coordination between the science and the managers. And that science coordination group has been in place for a long time, but it has some challenges. We do very well, I think, at communicating science and what we're doing to each other, but we still have some of the same challenges of actually pooling resources and coordinating. Each one of the member agencies that have science activities have their own charges and reasons to do their science, and it's very difficult to get everybody together and let loose of some of that in order to do things together. That's been a major hurdle. And some of those things they're required to do are required under lawsuit settlements or under legislation. So it still is a challenge to take our science dollars and put them together and use them in an effective way. I thought I had 45 minutes. 12:15? Okay, I'm sorry. All right. All right. So I was going with 45 minutes. So I'm just going to go right to the end then. I've already talked a little bit about that. I'm going to skip over funding. And I want to talk about one thing right at the end. First of all, we have a number of websites where we use common websites to put our data. The South Florida Water Management District has a website called DB Hydro that's accessible to the public. It's free of charge. You can get all of their hydrologic and water quality data. We have federal websites as well. We have common models that we use across these entities, which are very important because, in particular, the South Florida water management model that Obi's sort of the master of, in my mind, started out, I don't know what year, Obi, 1980s? It was an analog model with plugs you put in boards, you know, like that. So it's got a long history. It's much more sophisticated than that now, and it's a very important tool. We have a lot of collaborative approaches. We have an interagency modeling center that's housed at the Water Management District where we actually put modelers from different agencies in one place. We have a strong peer review component, including the National Academy of Sciences, and we use adaptive management. I'm just going to end on one thing, that co-production I think is really important, and I think we have an award-winning, in my mind, way of doing that. And the reason we can do it is something that you may not have access to always. As the task force has a FACA exemption, that's a Federal Advisory Committees Act exemption. So when you have a FACA in place, imagine a public meeting where the public gets to come up to a podium for 2 or 3 minutes, make their comments, have no feedback from the recipients, and that's the public stakeholder involvement. We've taken that to the entire opposite direction, where starting in 2009 with one of our restoration initiatives through the Water Management District, we did a workshop setting for developing restoration alternatives, where literally this number of people in this room would come in for 2 days, sit at tables in smaller groups, develop restoration alternatives, draw them out on maps. Circling in the room, you would have engineers and scientists from all the agencies being resource suppliers. So if you had one restoration alternative, you could pull over an engineer and say, I want to put this here, is that doable? And you'd have this real-time interaction that went on for several days. And in the end, you might have a dozen restoration alternatives drawn up. The agencies would take those and then work them up, run them through the models, and then come back in 2 or 3 weeks and have another one where the outcome from the modeling and the technical analysis was now put back to all the stakeholders. And this would go on iteratively, and in one case it went on for about 9 months. It's a very hard thing to do. It's resource intensive. It takes everybody at every agency all of their time for that time span to be responding to that, but it paid really big dividends in that all of the stakeholders truly felt that they were at the table. And in fact, some of their ideas were absolutely incorporated into restoration alternatives. So I could give you a lot more information about that, and a website where some of that information is put into more focus, but I think that's something that we've done well and is worth looking at. Thank you very much.
We have time for a few questions. Carl?
So, Nick, I'm not so much interested necessarily in the enterprise part of it, but the decision-making process as part of taking an adaptive management action. And are there examples of where you've run through that? It sounds like you put a lot goes into the planning, but completing that loop to come back and see whether or not it worked.
Yeah, I would say, in my opinion, I've worked a lot in adaptive management over a long time. What we use in the Everglades, we're calling passive adaptive management. We kind of fit it in because that was sort of an emerging field early on when some of this stuff started. And what we're trying to do is, along the way, have enough indicators and system status indicators and targets for restoration that as these projects are put into place, that as they achieve some of the results, we are able to use that science and make course corrections. We've not gotten to that point on any of these projects. In fact, one of the criticisms we get a lot of times is that some of the central major restoration projects are just now starting. The ones that have been completed or in place now that we're measuring are kind of out on the periphery, and we do have that kind of program in place, but I can't think of yet, unfortunately, one where it's just a matter of time, but there's not an example I can use from the Everglades where we've gone down a particular path, seen that the results are suggesting a change, and actually made that change. It's just, I think we're too early, unfortunately, in that stage. I would love to hear examples from anywhere where that's actually happened, because I'm not sure I can think of one yet. But
Bruce DeGennaro, Essex Partnership. Nick, The Science Coordination Group, I was just curious how much they just focus on coordination and communication versus thinking about priority setting and directing the science.
Right, so it's a combination of two things, and also I mentioned that Recover has a similar function for the big ecosystem restoration project. But for example, when 4 years ago, when we embarked on our latest sort of major restoration project, which was just recently authorized by Congress, at the beginning of it, the Science Coordination Group sponsored sort of a new science workshop. We had done this back in the 1990s when the original restoration plan was put into place. There was a foundation of science in it, and it was well established. But now we were taking the next step. A lot of new information had been gained over the ensuing decade and a half, and so we put together a 2 or 3 day workshop where we brought in everyone that's involved in new science that could be brought to bear. And for example, some of the things that happened for the first time is that we were actually able to apply ecosystem modeling to selection of restoration alternatives. We've always had hydrologic modeling, but now the field of ecosystem modeling had gotten to the point with enough models, whether they're single species models or larger scale vegetation models, where they could actually be approved by the Corps and used in the decision-making process. So the Science Coordination Group was the vehicle by which that occurred, which we could bring in all those people to talk about it. And again, because of our FACA exemption, we were able to do it in a way that perhaps some other federal agencies by themselves wouldn't have been able to do. And again, that's the good story. The thing that we still have not succeeded in my opinion, is the truly integrative approach where we might have one agency that really is strong in, you pick it, hydrologic modeling, another agency that really has a core of expertise in ecological modeling. So instead of both of us trying to do both of those things, let's divide up the pie and focus on our strengths. We're not there yet. It's a challenge because each of those entities have their own budgets, their own charges, their own governance structure. And so I think that's a common thing we all face when we're trying to make sure that we merge and get the most bang for the buck out of our science efforts. I think where it has succeeded, the Science Coordination Group approach, is that it's been a really good forum for direct interaction between the science and the policymakers. And it's not uncommon at our science meetings to have a really heavy attendance by policymakers and managers when we go out of our way to produce sessions and information that are useful to them. I think that's the key thing.
Nick, I have a question. You have a senior executive level representative of the Department of Interior who's assigned to work full-time in the Everglades. Has that made a difference in terms of the way your program operates and the way the overall progress of Everglades restoration has been occurring?
Yeah, it certainly has. So I mentioned that the South Florida Ecosystem Restoration Task Force is chaired by the Department of Interior. The Department of Interior then turned and created a position that's the executive director of that task force to sort of coordinate and put a lot of that into place. So that is an SES level position. There actually used to be 2 SES positions. That's been downscaled to 1 with 1 retirement. But that's one person that has a small staff that coordinates those meetings, coordinates the activity, is the interface between what we do and largely what happens up in D.C. in terms of communication with Congress and staff and Interior. That person in this position right now, it's Shannon Estineau. She reports to our Assistant Secretary for Fish, Wildlife, and Parks. So it's a relatively high-level position. She has no authority over anyone. She's it's no line item authority or no budget authority, but it's certainly because we have the background of this task force that was created by Congress. There's a coordination emphasis on that's worked pretty well.
Nick, you mentioned the greater use of ecosystem modeling and vegetation modeling, and you also mentioned that the modelers have a place where they can come together in a centralized location. Could you tell us a little bit more about how that was developed and how that's working?
Yeah, Obi's probably, but can you actually pass the mic to Obi right behind you? I can answer it, but he can answer it a lot better. So that's Jayantha Obi-Sakara.
Yeah, I think that's a good question. Early on, there were dueling models and not agreement among modelers between the Army Corps Water Management District and the Department of Interior. So actually, I was involved in starting this entity called Interagency Modelings, and the idea was to have a place where all the modelers from different agencies can come together and work on the same models and analyze the plans and basically communicate the results to the decision makers. We had some challenges along the way to get some agencies to, come in, because I think there was a feeling maybe you lose some independence, or because once you put a plan together, they all have to speak in one voice. It's been successful so far. So in our office, we have Army Corps and Water Management District and the Park Service have a couple of people. We work together on the modeling, and in the model development, we work together. Any changes to the model, we work together. So that has been fairly successful in implementation. It's called IMC.
Thank you.
That's a good example of co-production, actually.
One last question from anyone? Everyone hungry? Okay, thank you, Nick.
Thank you.